Hey, hello everyone, Assalamualaikum, and a very good afternoon to you all and YouTubers. Here, my name is Izzat Aiman bin Ibrahim from Group 12 Wireless. We are doing the experiment about wireless power transfer. Okay, here's my friend Fadhli, Raimi, and the cameraman. Ooh, key in. Now is the material for the experiment we are conducting, which is a wireless power transfer. That's the component with a 4.7 nanofarad, which is a foil capacitor. All we need is a foil capacitor. Why? Because the enhancement inside the element of the component is rebuilt with a conductor and non-conductor, conductor and non-conductor. It's like this. I will show you. So you can see here the white one is conductor, while the black one is non-conductor. The layer have been one by one replaced so that it can help the heat inside the capacitor from being lost outside. While for ceramic, you can show you the ceramic here the ceramic capacitor. It can overcome the heat, excessive heat compared to the foil capacitor. That's why we use the foil capacitor to conduct the experiment, as we need a frequency resonance similar as the part A and part B. Okay, so next is the 100 nanofarad, 15 nanofarad, 1 nanofarad with a foil capacitor. Okay, next is the transistor code BD139. We can also put BD135, BD137. They both work similarly, but we need to identify the data sheet. Here is the C, here is E, emitter, the middle one is C, collector, and the end one is base, B. Okay, next we need an LED. LED is basically a load, which we need to see the LED glows. Okay, next we need a 5.6 kilo ohms. Why we need a resistor? So that we can stop the current flow through it. If an excessive current flow through the circuit, that might blow the LED in the next part B. Okay, last but not least, but the component that we need is a coil. Coil is basically made of wire. See, this is conductor as we normally use it, and this is a non-conductor. Overlap them using this to tie the wire. You cut into small pieces, and then tie it between them with a 5-turn coil. See what? 1, 2, 3, 4, 5. Here is positive and then a negative. Okay, here are some construction of our experiment. Wireless power transfer. Have a closer look. This is a construction, part A, and here is a part B, which there are 3 LED we are testing without a capacitor, foil capacitor, and the others with a different value. Okay, this is how is the construction. I will show you on this paper. Have a closer look. Okay, we know that the BJT, which is bipolar junction transistor, BEC. Okay, this is basic ones. Okay, here are the construction. We put a capacitor here and transistor here, BEC. Next, we put a resistor parallel with a capacitor. And for the collector, we put a capacitor too. So then we put a ground in here. Okay, this is the construction of the circuit. But then we need a coil. So we pull a coil and round it here. And then for the negative coil, from here to here. This is a negative and a positive. Okay, we are done with the construction for an ideal construction. So next we comply the original, the practical experiment. Here I'll show you. I'll draw it to you. So we have the transistor, looks like transistor here. This is the head in front and this is back. Closer look, there's a LED here. Okay, this is emitter, collector and base. So there are 3 legs for it. Okay, I show you the practical way. Okay, so we have E, C and B. So the first one, as we look in here, it is the capacitor here, above here. See? Okay, to here. And then we pull the capacitor here at the collector here. And then for the base, we see base, there's a resistor and a capacitor. So resistor here and a capacitor parallel to it. So we see that these two are connected together. Then we build one connection here. Then we put the positive and negative terminals and here. So this is the negative. So I should show you how we want to apply for the dry cell. For a dry cell, we mean battery. So this is a positive and a negative. So positive here, we comply it in here to positive. So means that here is positive. And down here is a negative. Negative, negative. So then we pull out for the coil. So we have to pull coil. Coil. For the first coil. And then the second coil we need to intercept with the first coil to this collector, and another coil to the base. So our construction now are complete. So we can show you the real construction on the ideal breadboard. Have a closer look. The construction of the transistor can see here in front. Have a closer look. It's the in front, the head, where it is E, emitter, collector, base at the end. Okay, so the emitter, we put the positive terminal here, positive, and then negative. Positive at here and negative. See? The green one, the positive terminal, and this is a negative terminal. We're connected to the 100 nanofarad capacitor, the big one, which is at the collector. So for the the emitter, the collector now, we put a capacitor of 4.7 nanofarad. Okay, and for the base, we put a resistor of 5.6 kilo ohm, parallel with 1 nanofarad. Okay, for the second part, we need to build a coil with 5 turns with an LED. Okay, for the green one, we see that there's no capacitor to it. We will observe it later, and we can see for the yellow, there's a capacitor of 1 nanofarad, which will be observed later. We can see the difference with the red ones. The red is a 15 nanofarad, which gives a higher efficiency of the true bright color that glows for the LED. Okay, for the experiment, we can show you. For the green one, the first experiment, we have to put closer. See? It glow. You can see the distance. See the distance. We need to put it closer, as it doesn't have a capacitor. Whichever resonance capacitor. So resonance capacitor, how it works? It uses a right hand grip rules. So right hand grip rules is where the rotation, it goes like this. So the current goes up. It works similar as the magnet. Okay, I show you here how the magnet works. We know that here is north and south pole. So it moves above, and then for south it enters. Basically, for a magnet, it rotates like this. It will go into the south pole. Similar for the induction here, you can see that coil. You can see that the coil have a similar concept, which is induction. So an induction occurs like this. I'll show it. So we know that the coil is like this. So it enters with a magnetized field. It goes up and down into it. When we apply another coil here, as we show you above, at the green LED, okay. So when it enters, the magnetization field, it enters in here. So it flows the current from part A to part B. This is why it is called wireless. Okay, we can see here, there's no connection between it. Only the magnetization field connected them together. See, no item. You can see as I put a paper and it still can glow. See? Okay, for the next one, we put a 1 nanofarad. Can see? Here's a 1 nanofarad. 1 nanofarad. How much distance it can go? A bit similar, but quite increase the distance as we put a capacitor. The capacitor works as a resonance. A resonance, I can give you a sample of the glass. That frequency reach the same frequency as the glass. If you give a frequency that reach a glass, it will break at the same frequency when it reach the same frequency. Other example is for the experiment of the bridge. 50 years ago, there's a bridge that collapsed due to the wind frequency that reached the resonant frequency for the bridge. So the frequency of the bridge and the wind equals, so it will vibrate between the bricks and the road. So they collapsed. So it occurred so many incidents that time, accidents on vehicles. Okay, we continue our experiments for the red LED with a 15 nanofarad. This is 15 nanofarad. Okay, you can see it. It's a very high distance. Okay, you can see it. See? It glows with a distance of around 6 centimeters. Look. Okay, when we put it closer, it's getting brighter. Why? Because the magnetization is closer. As you can see here, the distance becomes near, the voltage and current flows through it increase. So we can see the practical. See the glow, how it glow, getting darker, looking brighter. Look how it goes. Okay, for the next one, we put all together the 3 LEDs. What happens? See? All glows with a distance, not touching each other. It still gives the same voltage and the same brighter. Why? Because it works like a parallel. Although it looks like a series, it is parallel. Okay, we're done for that, and we have the voltage. We can measure the voltage by using multimeter. Using multimeter, so we can see there we have a 6 volt supply. 6 volt supply, power supply, DC. So we can measure the resistance. How much? Look at the multimeter. It gives a rise from 6 volt to 8.16. It increased. As for VGT, current control voltage, BJT, while for the JFET, voltage, VGS control the ID, I current at the drain. For a capacitor, still do the same as it's parallel. So that's all for today. I've shown you how it works. Okay. Thank you for listening. Goodbye. Assalamualaikum.